Hey everybody, we're going to spend a little bit more time on scientific notation. All right, so let's take a look. Scientific notation is a great way to write really large numbers and really small numbers. So the approximate distance from the Earth to the Sun we have here, which would be an example when we would use it for really large numbers, and the approximate mass of a hydrogen atom is right here in kilograms. I don't even know how to say that. So that is a very small number. So scientific notation is a way that we can make these easier. So our learning outcomes today are to explain why scientific notation is used and convert scientific notation to standard form. And we won't really do the comparing part, but we're going to stick with these two right up here. Alright, so scientific notation is a neat and quick way of writing very large and very small numbers. So we have a times 10 to the power of b, where a has to be greater than 1 and less than 10, and b is an integer, so the little exponent. Here is an example where we have 2 3/10 times 10 to the power of 6. So here are the different parts of scientific notation. We have our coefficient up here, and we have our base right here of 10, and our exponent here of 6. So this part should be familiar with the current unit we're working on. This part you should remember from when we were combining like terms, and in our equations unit we talked about coefficients as well. Oops, didn't mean to do that one. Let me unblur. All right, so scientific notation in standard form. This is when an exponent is positive. What do you notice? And this is when an exponent is negative. What do you notice? So we've got the same coefficient, same base, but our exponent is different. What do you notice about the two different numbers? All right, you should hopefully notice that this one is not written in a decimal, but this one is. So if an exponent is positive, we move the decimal to the right. So the decimal is right here, we move it over 6 times to the right. If it is negative, we start with the decimal here and move it to the left. That's a big part you need to learn, okay? So knowing what to do if it's positive versus negative. So here would be some other examples on when you would use scientific notation. How many times the human eye blinks? What's the average width of a human hair? How many cell phones are in the US today? And how wide is a cell plant in meters? Let's see if we can find the answers. So this is how many times you're blinking. Scientific notation, standard form. Scientific notation, standard form. Scientific notation, standard form. Scientific notation, and standard form. All right, we're going to skip the ordering for right now. All right, so scientific notation is a shorter way of writing large or very small numbers. Don't forget that A has to be in between 1 and 10. All right. Done.